Next up, we have Copper-Sulfate Pentahydrate. What is the Roman numeral 2 for in the name? Charge of copper, because these are transition metal. And the pentahydrate means this thing here. There's penta 5 waters. And this dot does not mean multiply. It actually means like that it's in between the particles. It's in between the copper sulfate, which is why you don't see it as a liquid. Okay, and we'll talk about that later this year. But notice the pretty blue color. What's the pretty blue color probably from? From the transition metal, the copper, good. And also notice, except for this weird pentahydrate thing, that we have 3 elements, copper, sulfur, and oxygen. So that copper, sulfur, and oxygen indicates we have a polyatomic ion, which we'll be talking about later today, because there's more than 2 elements together in a compound. All right, so I'm going to go ahead and try to dissolve some of this. Oops, I need more water. And soluble. It all dissolved. Okay. Put a little bit in my well plate. And do a little test. And bam, it is a good conductor. Next, we have dihydrogen monoxide. What's another term for dihydrogen monoxide? Water. So I'm just taking my water. Does it dissolve in water? Yeah, right? There. Is it flammable? No, we use it to put out fires, right? And does it conduct? Where did I put it? There it is. It does not conduct. Now, the red light, I didn't dry this. That was my bad beforehand. But notice the green light's not even on. Okay? It does not conduct. Oh, good question. People asked that last hour. How can you get electrocuted when there's water? Is this a good conductor? Okay, tap water is a good conductor. Why is tap water a good conductor but pure water is not? Yep, there's dissolved stuff in tap water. In fact, they also put fluoride in our tap water, which helps to kill bacteria, but it also helps our teeth in the United States. But yeah, there's lots of other things in tap water that is not in pure water. Okay? So that one probably threw you for a loop, I'm guessing. Next up, I have something called sucrose, also known as table sugar. And we always say table, like table salt, table sugar, because we literally use it on our table. And hopefully you already know whether it will dissolve or not, but now since I know it's sugar, I can put my thumb over it because it's safe enough. And those are all little bubbles from shaking it. The sugar dissolves. So the sugar's soluble. And let's see if it conducts. And it's just that little red light, so no, it's not conducting. So the other reason why we're getting the red light, not just because of contamination and stuff, but also because when carbon dioxide When carbon dioxide in the air dissolves into the water, so after this water's been sitting a while, the carbon dioxide that's in there, some of it dissolves, and that carbon dioxide creates what's called carbonic acid, and then that's what makes it conduct a little bit. So that's why we get like barely, that red light is just kind of barely turning on. So really the water itself is not a good conductor though. So sugar water does not conduct. Next up, we have methanol. And just a tip, if anything ends in -ol, that means that it's a type of alcohol. There's many different types of alcohols out there. So we have our alcohol. And it's a liquid at room temp. And it dissolves. Those are bubbles from shaking it, but it does dissolve. If it didn't dissolve, it would be almost like oil and water where we'd see like 2 levels in here, okay? And then since it's a liquid, I'm gonna test its pure form. Oh wait, before we do conductivity, I'll do flammability. So flammability, I take a piece of paper towel, I rip it off, make it into a strip. Great question. That has to do with something called specific heat, and we'll be talking about that later this year. So we'll see. And I'll also show you when we're done if the paper towel burns or not. I mean, that is if this is flammable. I don't know. Yeah. So again, if anything is possibly flammable, we always cap it off before and we move it. Okay. And the way that we use our matches, we have it turned inside out. We put this about 1/2 to 3/4 of the way. Gently press, pull. And whenever we do it, we never want to hold a match like this, whoops, because that's going to hit our hand, right? We always want to hold the match up like this or sideways. Up is best, okay? Same with our substance that we're lighting. And sure enough, it is flammable. We're going to let our match cool before we throw it out. So then, let me cool this off. To answer your question, you say, you'll see that some of it did burn, but some of it didn't, okay? But we'll talk later this year about, like, why did some of it not even burn, okay? Okay. That was methanol. Next up, and of course now you can decide if it's ionic or molecular if you didn't yet. Carbon. Oh, we didn't. What was it? Methanol. Sorry. Lo siento. Whoa. I dropped my stopper. Ay. There we go. Okay. Where did I put it? Hopefully I put it there. I think I put it there. Conductivity. Niet. Not conductive. And that was methanol, by the way. I lost you. All right, next we have carbon. Carbon is just an element, just plain old elemental carbon. And it does form a compound, lots of carbons together. And we'll talk about that later. What does this look like? What does this substance look like? Something that you could think of. Pardon? Burnt toast, yep. What's that? Dark dirt almost. Dark chocolate, yeah. Coal, okay? So like burnt toast, coal, something that's burnt, soot. So those are the things. Now, what I did was last hour, or actually I'll just do it again just so that you guys can see firsthand. So it's a solid. And when I put it in water, and I mix it up, it looks like it dissolves and just, you know, changes the color of the water, right? But this is from last hour after it's been sitting for a while. You can see that over time, whoops, Yeah, lighter background is better. Over time, it settles. So it does not dissolve, so it is insoluble. It is insoluble, which means that we're not going to test it for conductivity in water. There are some things that might dissolve slowly, but you'd still see some of it dissolving in the beginning, okay? Because most substances are pretty quick when they're going to dissolve.